Let's take a look at topic 3.7. We're going to do transformations of cubic and quartic functions. This should look very familiar to you. It is exactly what we did with quadratics back in topic 2. The only difference here is when we studied quadratics, we had H and K, which represented the vertex. Now we're just going into C, D, but everything, any kind of effect that these values have on the graph is going to be exactly the same. So let's jog our memory. Your A value, that's going to be out front. If the absolute value of A, meaning if there's a negative out front, you just ignore the negative. If it's greater than 1, you have a vertical stretch. If the value of A, again, disregarding any sign, the value of A is between 0 and 1, so it will be like a proper fraction or a decimal. You have a vertical compression. If A is negative, that's your reflection over the x-axis. Coming in and looking at that C value, and again, notice too, that subtraction, that is part of our form here. So that's my horizontal shift. And again, remember, anything that's next to the x has to do with horizontal movement. Anything that is outside of your parentheses has to do with vertical movement, your y values. So horizontal shift, if you have an x minus c, that means you are moving right however many units c is. If you have an x plus c, you're going left c units. And again, remember, it's going to be positive because if my c value is negative, and I'd input it in here for C, I'd have a negative, negative C. Negative, negative makes it positive. Your D value, D is your vertical shift. It's up or down. And if it's positive, you're going up. If it's negative, you're going down. And in your form here, this N is your exponent. So in general, now this topic just goes through cubic and quartic. This applies for anything. You could have a degree of 2, a degree of 3, a degree of 4. Degree of 5, 7, 15, 25, these transformations will still apply. Let's take a look at some of these examples. So if you're going to take a look at a function and see how it's been transformed, this was a cubic, so I'm looking at my parent function x to the third. I've got a negative out front, so it's reflected across the x-axis. I've got a minus 3. Well, 3 is my C value. That's 3 units to the right. I've got a plus 4, 4 units up. On the second one, notice you have that 2 in front of the x, so you're multiplying. So anytime you multiply, if you're multiplying any number by 2, isn't it getting bigger? So that's stretching it. This is a vertical stretch. Notice I have no parentheses. That means there is no horizontal movement. And if I have a negative 5, a minus 5, I'm going down 5. Now let's write some equations from descriptions. Here we have a parent function of x to the third. It's going to be reflected across the x-axis. Horizontal shift left 5, vertical shift down 2. So here we go. I'm going to write this as f of x. So I'm just reflected. There's no stretch, no compression, so that's just going to be a negative. I have a horizontal shift. If I am moving left 5, that's going to be a plus. 5 is going to be, this is going to be a negative 5 is my C value. My parent function is cubic, so this is going to be cubic. Vertical shift down 2, so that's minus 2. Here, the next one, I've got a parent function x to the fourth. I'm going to move it right 3 and up 1. F of x equals, so if I'm going right 3, remember your form already has the negative. My C value is a positive 3. My exponent is going to be 4. And I'm moving it up 1. And one more. I've got a parent function of x to the third. It's being vertically compressed by 1/2 and a vertical shift up 4. Notice there is no horizontal movement here, so I don't need the parentheses. My compression, that's my A value. It is going to be to the third power. I'm not writing any parentheses. My C value is 0. Up 4.